To my video on surface area, changing attributes of a rectangular prism. Now, recall when we talked about volume in attributes, we said that the attributes were length, width, and height because that's what was describing the rectangular prism. And remember when we did volume, if we doubled one of the attributes and only one of the attributes, then it doubled the volume. Or if we tripled one, then it tripled the volume. Or took half of one, then it took half of the volume. Okay? Now think about what might happen with surface area. And that's what we're going to discover today. So recall that surface area is the sum of the areas of the surfaces on the container. Okay, so here's the original prism, and then we're going to double the length, double the width, and double the height and see what happens to the surface area. So remember, let's see, the length. If we double the length, we get 6 centimeters. If we double the width, we get 8 centimeters. And if we double the height, we get 4 centimeters. Now notice when I was doubling the length, I kept the other two the exact same, just like the original prism. Okay, now, before we can answer this question here, we need to calculate the surface area. Now, for our note purposes, I'm only going to calculate one because you already know how to calculate surface area. And then once we calculate A, we'll record it, and then I will tell you what the others are. Okay? So down here in the workspace, label A. Okay, and our first step is to, let's circle A, write the formula. So surface area equals 2LW plus 2LH plus 2WH. Now, we're going to look at the chart and figure out what the length and the width and the height are. So bring down your 2. The length is 3. The width is 4. And remember, box it in, because order of operations would tell us to do that part first. Bring down your plus sign, 2. The length is 3. And the height is 2. Box it in. Bring down your plus sign, 2 times the width, and the width is 4, and the height is 2. Box it in. Now, I'm going to multiply each part together and then add it up. So 2 times 3 times 4 is 24. 2 times 3 is 6, times 2 is 12. 2 times 4 is 8, times 2 is 16. And if I add that up, I get 52 centimeters squared. Circle your final answer. And remember that your label is always squared for surface area. Now, let's go back to the chart. We're going to fill in the 52, and I'm going to tell you what the others are. I'm not going to make you figure out B, C, and D. So, 52 centimeters squared. Now, the prism B is 88 centimeters squared. Prism C is 92 centimeters squared. And prism D is 80 centimeters squared. Now, we doubled each attribute, okay? And the original was 52. Did any of the surface areas double? No, because if the surface area had doubled, one of them would have been 104. Now, did the surface area increase? Yes. And let's just write our increase over here. This one increased 36 from the original. From 52 to 92, it increased 40. And from 52 to 80, it increased by 28. Okay, so let's compare the surface area of your original prism to the surface area of the new prism and explain how changing the attribute affects the surface area. So here's what I want you to write down, and this is what I wanted you to see. All of the surface areas increased but did not double like each of the attributes did. Okay, so remember, this is different from what volume did. When I did this during volume, if I change one attribute by 2, then the volume doubled. But notice, when I multiplied each attribute by 2, for the surface area, none of the surface areas doubled. So that's the difference between changing an attribute of volume and changing an attribute of surface area. So now turn it over to the back. And now we're going to look at what happens if I reduce it by a scale factor. We increased it on the first page, now we're going to decrease it. Okay, so we have our original length is 6, width is 4, height is 2. So if we take half the length, we're going to get 3 centimeters. If we take half the width, we're going to get 2 centimeters. And half the height is 1 centimeter. All right, so now let's go down below, and we're going to just calculate the surface area, because these are different numbers. We're going to just calculate the surface area of prism A. And if you would like to pause the video to see if you know how to calculate surface area, then go ahead and pause the video after I write the formula. So surface area equals 2LW plus 2LH plus 2WH. Okay, now you can pause the video if you would like. Okay, welcome back if you pause the video. So bring down your 2. Okay, the length is 6. The width is 4. Box it in. Plus, bring down your 2. The length is 6, and the height is 2. Box it in. Plus 2. The width is 4, and the height is 2. Box it in. Now I'm going to calculate each part. 2 times 6 is 12. 12 times 4 is 48. 2 times 6 is 12. 12 times 2 is 24. And 2 times 4 is 8. And 8 times 2 is 16. And when I add all that up, I get 88. What's our label? Centimeters what? Squared for surface area. Remember, volume is cubed. Surface area is always squared. All right, let's go back to the chart and fill in the 88, and then I'm going to tell you what the others are. All right, so we had 88 for the original, centimeters squared. Okay, B is 52 centimeters squared. C is 56 centimeters squared. And D is 68 centimeters squared. Now, what do you notice when I compare all these to the original 88? they all decreased in surface area, right? They all went down. So let's write the decrease over here. This one went down by 36. This one went down by 32. And this one went down by 20. Now, do you know what half of 88 is? Good, 44. So did any of them get cut in half? Absolutely not. So we can write similar to what we wrote the last time on the first page. All of the surface areas, now this time they decrease, so all the surface areas decreased but did not half like each of the attributes. Now what I'm saying here is all the surface areas went down, but they did not get cut in half like the attributes. Remember, if this was volume, then the volume would have been cut in half. But surface area? Nope. So does scale factor apply to surface area? Meaning, if I take half of the length, is the surface area going to be cut in half? No. So scale factor does not apply to surface area. Does it apply to volume? Yes. Okay, that concludes our notes on changing attributes of surface area. I hope you have a great day.